everyone.
Yes, sir. I will start then.
Yeah. Yes, sir. Start,
So, good morning to all. We are very happy to welcome you all for the final day of this faculty development program organized by Institute for Energy Studies, Anna University, Chennai, sponsored by AICTE Training and Learning Academy. On behalf of Institute for Energy Studies, I would take this opportunity to extend my hearty welcome to the guest speaker of this session, Mr. Karikal Cholan sir. He has did his BE from NIT Tiruchi and MTech from IIT Delhi and currently working as additional general manager corporate planning development department at New Delhi. He has 22 years of industrial experience and started his career with Tata Steel, Jamshedpur in 1998 and later he joined NTPC Limited in 1999. Since then, he is with NTPC Limited, a Maharatna company under Ministry of Power. Also, he has worked with various power stations of NTPC Limited. Uh, he has worked for 14 years at NTPC Ramagundam and 5 years at NTECL and 2 years at NTPC Faraka. And also, he is a certified energy auditor by Bureau of Energy Efficiency. And with this brief introduction, now I request you to deliver a lecture on experience of energy audit in thermal power plant, sir. Over to you, sir.
thank you, sir. Good morning, everyone. Let us make it an interactive session. Whatever experience I have, let me share with all of you in the area of energy audit. I've been working with NTPC since last 22 years, and I've been with O&M department, that is operation and maintenance of thermal power plant. And we have been practicing this energy auditing as part of our effort to increase our revenue and increase our bottom line, that is profit. Since we are in a regulated business, our profit comes through the difference between how much you are paid for and how much we spend for. Say, for example, if you are given 100 rupees salary and if we spend 80 rupees on our expenses, our saving will be only 20 rupees. The salary is fixed. That is, the regulator fixes the tariff for us. That is, what is the cost of our power is fixed by the Central Electricity Regulatory Commission. The profit will be coming through how much we reduce our cost of generation. The difference between the cost of power fixed by the Central Electricity Regulatory Commission and the cost at which we produce, the difference is our profit. And we need to put lots of effort to make this profit more. So with this short introduction, let's go to the experiences of energy audit in thermal power plants. What is energy audit? Anybody can tell? Anybody who has an experience in this field of energy audit, can you define what is energy audit? What is an audit?
Actually,
Basically,
I'm not from the.
yes.
Yeah, actually, I'm not from the industrial background. Actually, I'm a assistant professor in the government engineering college. Actually, I think this is the another that means that utilization of this electric energy in different load systems and performance of the systems with the input of the input, that means the electricity. Okay, so the efficiency of the whole industry, actually, I think.
Yes, sir. Actually, see, it's for example, any audit, what we look at what should be the value and what is the actual value. What should be the value, the difference between what should be the value and what is the value that, and we identify the gap. That is the audit. In energy audit, what we do, what we know, what should be the equipment. So for example, if a motor is there, what should be the rating of the motor? So if there is a 100 kilowatt motor, it is drawing 100 kilowatt. And for a particular load, what should be the load versus the kilowatt? Okay, if you know that suppose if it is operating at 80% loading and it is drawing full load current, then there is a difference in the efficiency of the equipment. So we can know why that difference. So this way we know what is the established value, that is a design value versus actual value. So the difference, if you know what is the reason for the difference, then we can mitigate the problem and we can run the equipment at the optimal value. So energy audit is the first step towards systematic efforts for conservation of energy. It involves collection and analysis of energy related data on regular basis and in a methodological manner. All of you are aware that there is an Energy Conservation Act 2001, under which all the major energy consuming industries are identified as designated consumers. Designated consumers means where there is a defined energy consumption level, say thermal power plant, paper industry, cement industry, fertilizer industry. These are identified as designated consumers. They need to benchmark their energy consumption level for each ton of production. For thermal power plant, it is for each unit of electricity. For cement, it will be for per unit per ton of cement. For fertilizer, it will be per ton of fertilizer. So what is the actual energy consumption and versus the design energy consumption? Why there is a difference? If the difference is more than 5%, they have been given certain target to achieve, to reduce their energy consumption below the norms. That is the thrust of Energy Conservation Act. So according to Energy Conservation Act, it is the energy audit is defined as the verification, monitoring and analysis of use of energy, including submission of technical report containing recommendation for improving energy efficiency with cost benefit analysis and an action plan to reduce energy consumption. Right? So we need to benchmark ourselves with respect to the design or with respect to the peers. How much we can go down, so that if you reduce the internal energy consumption, what happens? We can supply more energy to the consumers. If we supply more energy to the consumers, we get more money, right? So what is energy management system? It is a fundamental goal of energy management system is to produce goods and provide services with the least cost and least environmental effect. Okay, not only we are reducing the auxiliary power consumption, but also we are reducing the carbon footprint. See, if you produce electricity at lesser coal consumption, for each unit of electricity we produce, what we are doing, we are reducing lesser CO2 emission into the atmosphere. And most of our power plants are operating on the fossil fuel, that is coal. In India, it's around 60% of the total generation is from fossil fuel. So if you reduce the coal consumption, will in turn reduce the carbon dioxide emission into the atmosphere. So anybody has any doubt or anything, just you can stop me and ask me. Shall we proceed, sir?
Yes, sir.
Yes, sir.
See, energy management is the judicious and effective use of energy to maximize profit and minimize cost and to enhance competitive position. The strategy of adjusting and optimizing energy using systems and procedures so as to reduce energy requirements per unit of output while holding constant or reducing total cost of producing the output from these systems. That is energy management. And we have an integrated energy management system at all our NTPC plants, in which we will come to know at each point of place what is the energy consumed for each plant, each equipment. More than 100 kilowatt, we have an energy meter, which will show you what is the energy consumption versus the load of the equipment. What is the importance? Say, we know we are consuming coal. So our unit of measurement for measuring the efficiency is specific coal. Specific coal is what is the coal consumed per unit of electricity production. Okay, that is kg per kilowatt hour. Kilowatt hour is nothing but 1 unit. For producing 1 unit, how much coal we use? That is our indication of our efficiency. If you consume less coal, it is more efficient. The other term used for our efficiency is the heat rate. Heat rate is the kilocalorie consumed for every kilowatt hour of electricity production. It is an indirect method of efficiency, that is inverse of efficiency. Heat rate is inverse of efficiency. If the heat rate is more, efficiency is less. If the heat rate is less, the efficiency is more. Okay. So for example, if you see, if we reduce the heat rate by 1 kilocalorie, then what is the impact for a 500 megawatt unit on an annual basis? It is around 46 lakhs saving for single 500 megawatt unit. And India, we are having around 260 megawatt of thermal generation. So you can calculate what will be the impact in the large scale. And in NTPC, we have around 45,000 thermal generation. So 45,000 megawatt. This is for a 500 megawatt, we are saving about 46 lakhs. And if you consider for 40,000, what will be the impact? And auxiliary power consumption, if we reduce 0.1%, it's impacting our margin by 1 crore 16 lakhs. That is the importance of energy saving. So if you look at oil, why do we use oil in power plant? In a thermal power plant, coal-based power plant, why do we use oil? Anybody?
Sir, to initially start the boiler, we require oil. Then we can change over to coal.
Yes. So that also plays a vital role for our cost of production. Not only for initial startup, but also we use oil during low load operation or during any equipment changeover wherein flame stability is affected, we use oil. So this oil, presently the cost of heavy fuel is around 45,000. If we reduce 0.1 ml, 0.1 ml is very meager amount when we consider. Okay, but for a 500 megawatt unit, it translates into 1.77 crore per annum. So even a small effort will lead to substantial saving in terms of our bottom line. That is the need for having energy audit conducted, energy conservation measures in our thermal power plant. What are the various systems in our thermal power plant? See how the coal is converted into electricity. First, coal we receive from mines through belts or through railways. Railway wagons, we receive coal and it will be unloaded into our coal handling plant. From the coal handling plant, we crush the coal and we'll send it to the pulverizers. In the pulverizers, the coal is converted into powder. The powdered coal is transported to the furnace, wherein the combustion takes place. After, to make a combustion, what are the important parameters we need? for what are the things required for combustion? Anybody?
Sir, we require the fuel and air for combustion, and the air should
Yes.
be treated at a particular temperature, and also the fuel
Yes.
should be at a particular pressure.
Yes. So we need
the calorific value of this whatever this coal powder. Calorific
yes.
value. You have to see the calorific value. Then after that,
Yes.
yeah.
So we need fuel, we need ignition energy, and we need air. So we supply air through fans. Okay. There are two types of fans used in power plant. One is forced draft fans, another is induced draft fans. Forced draft fans supply the combustion air, and the third type of fans used is a primary air fan. Primary air fan is the fan used to supply air to transport the coal from the pulverizers. Pulverizer is nothing but our we use in our home, no, to grind rice and other things. Earlier days we will be using two stones, one above the bottom. Okay, what do you call chakki? In Hindi they call it as a chakki. You know that. In houses also we use that for grinding materials. Okay, so that is the pulverizer. From the pulverizer the coal goes to the furnace, wherein the supply of air is aiding to combustion. The initial ignition energy is supplied through electrical arc ignition. It is supplemented through oil. The fire efficient ignition energy is reached and coal feeding will be increased. Gas stove. Initially what we do? We use the lighter. Okay. And in wooden firing what we do normally? We use kerosene. We put the small wood first, then add kerosene, then use a matchstick, and the fire is, once the fire is caught, then we withdraw the kerosene. Then we go on add wood. That way the combustion is ensured in the boiler. Then we have what is the product of combustion? What are the products of combustion? Anybody?
Steam.
Coal contains what? Coal
Steam.
contains carbon and ash. These are the major components of coal. Carbon is converted to energy. The ash becomes a molten state and it comes out from the boiler. So we have substantial energy for transportation and conversion of this ash for using in various places. So ash handling is another area where larger amount of energy is consumed. Then we also consume a larger quantity of water for our cooling and steam production. So we need to conduct water audit. Then we need to conduct steam turbine, wherein the steam produced from the boiler is used to produce electricity. Then we have a condenser cooling system, compressor system, fans and motors, air conditioning, lighting, and electrostatic precipitors for conversion of fine dust from coming from the furnace to capture it and use it as a fly ash. So these are the various systems in a thermal power plant which consume larger amount of electricity, for which we need to conduct audit and find out gap areas and make action plan for reducing the power consumption in each area so that we are operating at a optimal energy consumption levels. Okay. So till now, anybody has anything to ask? you please pause so that we can proceed further?
No, sir. No, sir.
So energy audit is conducted in two phases. One is preliminary audit, next is a detailed audit. In the preliminary audit, what we do, we just see that, say, seeing like your bank statement, you know what was your salary, what is your bank balance. So that will indicate what is your expenses. Okay. Okay, sir. So if you look at your bank statement, you can know what is your salary and what is your bank balance now. The difference indicates the expenses. Now, if you look at that statement closely, then we know where we spent, and we make a detailed analysis that each area wise, like what was our grocery bill, what is our gas bill, what is our school fees, like that one by one we'll look at, and we identify where we have spent, like whether we have spent more on movies or whether we have spent more on other unnecessary expenses. So that will come in the detailed audit. So in the preliminary audit, we'll know what is our income, what is our expenses, and we know what is the consumption. In the detailed audit, we'll go into the details of where we are spending in a detailed manner. So what is the scope of preliminary audit? It is to establish energy consumption in the organization. Okay, for example, in our salary example also, we can always fix what should be my monthly expenses for this month. Okay, then we can cut down the unnecessary expenses. If you don't fix the limit for our expenses, it is very difficult to cut down the expenses. So we need to first define what should be my consumption. Then we can identify area-wise consumption, where we can reduce the consumption. Then next what we do, estimate the scope for saving, where there is a potential for saving. Identify the most likely and the easiest area for attention. Like for a salary example. So if we are going to movies every week, we may reduce to alternate week. That is the immediate way of cutting down our expenses. Likewise, here also we can identify the areas in which we can reduce the expenses immediately. Then identify immediate, especially no or low cost improvements or savings. Set a reference point where we want to be. Then identify areas for more detailed study and measurement. Then normally the preliminary energy audit uses the existing or the easily obtained data. Right, sir? The detailed energy audit is carried out 3 phases. It has 10 steps. The first phase 1 is a pre-audit phase, that is step 1 and 2. Phase 2 is audit phase, that is steps 3 to 9. Phase 3 is the post-audit phase, that is identification of recommendation, implementation of recommendation, and identification of the savings through the recommendation. So that is the third step. In the step 1, what we do, it is a pre-audit phase. That is, plan of action includes plan and organize, walkthrough audit, informal interview with energy or production manager. Purpose of this step is to resource planning, establish, organize an energy audit team, organize instruments and time frame, macro data collection, familiarization of process and plant activities, first data observation and assessment of current level of operation and practices, build up of cooperation. The step 2, what we do, conduct a brief of meetings, awareness program with all divisional heads, persons concerned. Issue questionnaire for each department, orientation, and then create an awareness. Why this audit is required, what is the purpose of audit, and where they stand and where they can go. That is the purpose of step 2. It is buy-in from the people, because ultimately any audit, for its success, we need to get the support of the people who are involved in the actual field, where recommendations are to be implemented. If we don't get the support of the people who are involved in the work area, then we cannot implement any recommendation. Step 3 is the audit phase. In this, what we do, primary data gathering, process flow diagram, and energy utility program. What we do, we try to collect all the historic data and then baseline data, prepare process flow, where from how much energy is drawn and how much energy is consumed at various places. Design operating data and schedule of operation, annual energy bill, energy consumption, per ton. All these things can be arrived at in the audit phase. Then we do the survey and monitoring measurements. We do make the measurements of each area. Though we may have already meters in the area, sometimes what happens, those meters may be faulty. So to cross check the actual value of those meters, we normally use instruments for power measurement, and we compare whether these data is matching with the actual power consumption and what is the design power consumption versus actual power consumption. For each load, we conduct the survey audit for various loads. We conduct survey at 60% load, 80% load, and 100% load, so that we know with respect to various load, what is the power consumption by the equipment at various loads, whether it is in line with the manufacturer recommendation. Step 5, that is conduct detailed trials, experiments for selected energy guzzlers. So we need to have multiple experiments for various equipments. All the equipments we need to do at various loads, so that and also multiple experiments we should do, because sometimes what happens at a particular load, we might have done an experiment, but that time there may be changes in some other process which might have impacted. So to ensure that the data is properly derived, we need to repeat the experiment so that the baseline data is proper and it is correct. Step 6 is analysis of energy use. Now that we are after making the measurement, in the step 6, what we do, we know what is the power consumption at each equipment at each load. Then we draw a tabular form in which we will know like which equipment is consuming how much. Step 7 is identification and development of energy conservation opportunity. So now that we know what is the baseline energy data, what is the design energy consumption, and what is the difference. Now that we have to identify which are the equipments we need to focus on, where there is a larger energy saving potential. Then in the 8th step, what we do, we make a cost benefit analysis, whether particular effort, if it may result in a smaller saving, and with respect to the effort and resource required, that may be very small. So those areas we need to eliminate, and we need to focus on the areas where with a small effort, larger quantum of energy saving is possible. So the 9th step, we make the final report, that what is the state of the plan and what is the energy saving potential and what are the recommendations for achieving that energy saving in each area. That is the step 9. Then step 10 is the post audit phase, that is follow up and implementation and follow up. Then we need to help them to implement the suggestions which we recommended, and we must see whether the recommended suggestions are implemented and are they giving the expected savings. Okay, sir, these are the 10 steps involved in the energy auditing. So till now, if anybody has anything to ask, we can ask. We can spare for 2-3 minutes. Sir, anybody?
No, sir.
Okay, so then let's proceed. So let me go through various energy audits which we have conducted, and through which whatever savings and things which you are achieved. So I will go to the practical cases of what we have done at various plants. Okay. So recently we have conducted a lighting audit. What is the purpose of lighting audit? Anybody? First and foremost, purpose of lighting audit is to ensure the proper lighting is there at shop floor. The required lux levels are there in the shop floor. That is the first step for lighting audit. Second requirement, what is the second requirement of lighting audit? Whether the power consumption at each area, whether it is less or more. In all our plants, we have converted all our old light fitting to LED lighting. The entire NTPC, we can't, nobody can find any normal tube lights. Everything will be LED only, which has resulted in substantial savings in our lighting load. Each plant is able to save at least 1 to 2 megawatt of power consumption in the lighting. So the objectives of lighting audit is measurement and comparison of illumination levels at various locations, measurement of total power consumption of all lighting feeders, calculate the installed load efficacy in terms of lux per watt per meter square, compare calculated value with the norms for specific type of interior installations for assessing improvement options, to suggest ways and means to optimize the illumination levels and to optimize the power consumption at different locations, to identify energy saving measures and quantify the energy and cost savings. This is the purpose of lighting audit. Okay, sir. So in lighting audit, what we do? We do data collection, observations, measurement and analysis, exploration of energy conservation measures with detailed techno-economic analysis, and then prepare a report for various savings. Right? So you can see that what we have done in recent one of our plant, how much measurements we have done, and what is the potential for each area. Okay. So you can see this. Against target of 52 lux per watt per meter square, of 52 we were having 18. So we recommended immediate action should be there. Urgent action required as ILER is less than 0.5. So like this we recommend, and we make a action plan for each area to reduce lighting power consumption as well as to improve the lighting in that particular area. You can see that lux levels at various plant locations. What is the average lux and what is the recommended lux? So this way we help in achieving safe working environment for the people, and also we help them to reduce the energy consumption in each area. Right, sir? Anything on this lighting audit? Sir, anybody?
If the participant has any questions, they can ask, sir.
Okay, sir. Let's proceed then.
So we will have the session at the last, sir.
Okay, sir.
after completing the lectures.
So next we have done insulation audit. In a boiler, large amount of heat is radiated outside the boiler, which increases the ambient temperature. Also, it has a potential for higher fuel consumption because the heat which would have been used for energy production, that is steam production, as getting wasted as radiation. So the efficiency of insulation is very much critical for success of or improved efficiency of our boiler. So what we do, we have a IR thermography through which we make a temperature measurement of various locations of insulation, and based on the temperature mapping, we give recommendation for energy savings. So you can see the insulation temperature is 200 degree. That means that particular area needs immediate insulation replacement. We make measurement for various places. You can see 180 degree, 250 degree at the manhole, 170 degree at drum floor towards chimney, 200 degree boiler insulation floor drum top. So these kind of measurements will help us to identify the potential sources of heat loss, and also it helps us to improve the boiler efficiency. You can see the temperature profile through the IR thermography and the absolute temperature value. It is measured at various places. So that we are able to identify what is the insulation temperature at various places where the radiation loss of heat is more, and which will help us to reduce the fuel firing. So this is the potential for a 81.5 meter squared area. There is we have measured for 81.5 meter squared area. There is a potential of 9.87 lakhs per year. So if we make the measurement for the total boiler, there will be a huge potential. So this way we identify the focus areas and plan for insulation replacement during annual overhauling of the plant, which in turn helps us to reduce the energy consumption in terms of coal consumption, and which in turn increases our revenue and the bottom line. Right, sir? Then in NTCL Vallur, we have done a flame study in the boiler. The load, we have taken a reading at 340 megawatt and 420 megawatt at two different loads. The boiler flame was evaluated by checking from the topmost peepholes to the bottommost. So these are the following observations. What we have done was, we have taken through a camera, taken the flame photos and identified what are the problems. The flame was stable but very long, as seen from the peephole at 66.4 meter elevation. So this is just as the entrance of the vertical reheater. This area should be dull red in color or dark, but was bright. So if the flame is bright at higher elevation, what does that indicate in a boiler? If the flame is very bright at other than the boiler combustion area, what does that indicate? Anybody? Suppose if you look at a fire, you are firing at one place and you are seeing a flame in some other place, from nearer to that place but far off from that actual flame. What does that indicate? Anybody in common places? Suppose if there is a fire in one place and you are seeing some flame in some other place, what is that meaning? There may be a carry forward of this fire to that location. Okay. So in boiler also, if there is a fire other than the combustion area, that means the coal is unburned and it is carried forward to a higher elevation where there is a further firing take place, where we are able to see the flame, right? So that will indicate the condition of flame and the firing condition inside the boiler. So it should be dull, but it was bright, indicating that is a coal is getting forwarded, carry forward to a higher elevation where there is a secondary combustion. Secondary combustion is a waste of energy, and the energy which is supposed to be taken by the water in the boiler water wall is not being utilized at that particular place, and it is getting carried forward into a different location and is getting the energy is getting wasted. The PPOs provided are mainly for pressurized boiler and not required for balanced draft boilers. These are in very bad condition and required to be altered. Suppose these PPOs are open, what will happen? In a boiler, if the PPOs are open, what will happen? Anybody? PPOs are used to see whether the flame is in good condition or not. If we keep them open, what will happen? There will be a air from the outside ambient will go into the
fire
boiler
might come out.
Cool the boiler. It will cool the boiler. Okay. So what will happen if it cools the boiler? What will happen? The heat inside the boiler will be used to cool the air rather than heating the water. Right? That way, what will happen? Then to heat the water, what we have to do? We need to give more fuel. So these are walkthrough audit. Just by going through this walkthrough audit, we were able to find out how many people are open and what is their impact. And immediately they can be closed. We have a certain plans wherein if you open it, again it will close it automatically. If you leave it, it will open, it will close automatically. But that mechanism was found damaged in various locations, which we told them, please attend these and you can have a substantial saving in terms of fuel consumption. Right? You can see here in this picture, there is a kind of a lock. Are you able to see that? If you lift it, you can see, and if you leave it, it will get closed. Sir, are you able to visualize this? That lock?
Yes, sir.
You can just lift that lever and you can see the flame inside. Then once you leave it, it will go to that position and it will get locked automatically. Only by force you can take out. Such kind of people will be provided. That's what we recommended in all locations, which helps is in keeping the furnace airtight. So the part at 373 megawatt, the coal consumption was around 222 tons. The very milk combinations A, B, C, E, G, H were in service. Okay. So the overfire dampers were full open condition. What we recommended is you change these fuel air dampers and overfire dampers, various position. And by doing this, we were able to improve the combustion. And by improving the combustion, what is the effect? The unburned carbon in the fly ash and bottom ash, we were able to reduce. You can see this lot of fuel flame is coming out. So these things, we ask them to put the insulation proper and they will not come out. Right? So these water cooled manhole doors were also not insulated. So what will happen? If they are not insulated, the because of the radiation, the heat will go into the atmosphere and we will be losing a lot of energy. How can you know that complete combustion is taking place in a boiler? Anybody? How can you ensure complete combustion?
Sir, the hydrocarbon content at outlet, exhaust gas, that should not be there, and you should have carbon dioxide at the exit.
Yes, there should not be any carbon monoxide. C plus O2 gives you CO2. Okay, if it is a complete combustion. If it is incomplete combustion, it will be C plus O2 equal to CO plus CO2. Some carbon will convert into carbon monoxide and some part of the carbon will convert into carbon dioxide. And to ensure complete combustion, what are the two parameters that we look at it? We look at it, what is the excess oxygen at the outlet and what is the carbon monoxide. These are the two parameters we look at. Carbon dioxide, percentage of carbon dioxide, carbon monoxide, and excess oxygen at the boiler. So these parameters we looked at and we recommended that what should be the ideal values for these parameters, by which we were able to reduce the unburned carbon from 6% to 3% in bottom ash and 2% to 1% in fly ash. That was the recommendations of ours and which have resulted in substantial reduction in bottom ash, unburned and fly ash. You can see the trend of various units. There were 3 units in Vallur, 3 into 500 megawatt. So these are the parameters. And we have analyzed the coal. What are the sources of coal, from where they are getting the coal, so that the proper mixing of these sources of coal is also important for a proper combustion. Right? This is the for various units. We have done this study. This is a boiler. Unit 1, what is the carbon and ash percentage, volatile matter, and total moisture. This percentage also we made. This is a data analysis. Basically, energy audit is nothing but analyzing the existing data and identifying the potential areas for improvement. And after identifying the potential area for improvement, what are the steps we need to take to improve or harness that potential? That is how we look at it, energy audit as an area for improvement. Then what we do, we go whether this incomplete combustion is whether because of improper airflow distribution or because of the pulverizers giving fineness, that is a fine dust at a higher fineness than required. So these things will be giving it, so that how we can improve the consumption, energy consumption level, and we can improve on the efficiency. Right? Anything, sir, up to this point? If anybody has any doubt, please stop and because if it is a one-way communication, I can't understand whether something is going in your minds.
Sir, excuse me, sir.
Yes.
Sir, with respect to this coal fineness, like whether we'll be estimating the mill performance, sir, like the type of mill and the coal fineness, like how you correlate that one, sir? Like, have you done any?
Yeah, we have isokinetic sampling. Okay. There's a method called isokinetic sampling. The sampling also plays a vital role. How do you sample them? Suppose if you take the sample at a higher velocity than in the, see there is a velocity inside the coal pipe. The coal is traveling at a, coal powder is traveling at a particular velocity. Isokinetic sampling is sampling the coal at the same velocity of the coal pipe. If you take sample at a higher velocity, what will happen? The coarse particle, coarse particle will come into the sample. If you take the lesser velocity than inside the velocity, then we'll get a more finer particle. So we recommend that we should take the sample at the same velocity of the coal pipe, coal inside the coal pipe, and the sampling velocity should also be same. So that is called isokinetic sampling. We have an isokinetic sampler. We measure the velocity inside the coal pipe and set the velocity of the sampler at the same velocity of coal pipe. Then we'll measure the fineness of coal. There is a plus 200, minus 200. That is, they will be sieved through the sieving. Okay. So there will be through the sieve, we'll know what is the percentage of particle retained at each sieve. Okay. For a 75 micron size sieve, the percentage retained should be more than 70%. For a 75 micron sieve, the percentage retained should be less than 30%. The percentage of material passing through the sieve should be more than 70%. And there is a 1 plus 50 sieve through which the percentage of retained should be less than 1%. Percentage retained should be less than 1%. That indicates the mill condition. Okay, sir?
Thank you, sir. Thank you.
We need a coal size of 75 micron to go into the boiler for proper combustion. And because though the mill may be okay, but in each mill we will be having some 2 to 4 or 6 coal outlet, which will be going to the boiler at various and entering the boiler at various locations. So if there is a velocity difference, what will happen? Inside the boiler, we call an imaginary fireball. Okay, the fireball will get shifted towards one side. Then what will happen? There will be a improper heat distribution inside the boiler. So what will happen? The heat pickup from the water walls inside the boiler will be non-uniform. One particular place there will be a larger heat pickup, and one area the heat pickup will be very less. So this will lead to a particular metal is being overheated, and other place the metal is the steam temperature is getting less. So that way, what we do, we analyze the temperature of profile of the boiler also. That way also we'll know how whether the heat distribution inside the boiler is uniform. So what we do is normally during the trial we make a lot of adjustment in the overflow dampers, fuel air dampers, and we verify for the changes in the combustion, the temperature, the unburn profile. Then we measure the values and we see whether is there any improvement in the combustion parameters. Then that will give us the whether we are going in the right direction or we need to change the parameters. Then in this way, trial and error, we make the final adjustment and we reach the required value. And the testing was done at various loads like 425 megawatt, 480 megawatt, and various loads, so that whatever changes you make is not affecting the furnace conditions at different loads. So those when we make certain changes, we make load changes, and we see that whatever change we make is not affecting the boiler at different loads. So it should be whatever we change we make should be uniform across all loads, and the
Good morning all. Can you hear me? Good morning all. Can you hear me? Good morning.
Sir, good morning, sir.
Yes, sir. Yes, sir.
Thank you. So, in the last class, we seen about this interrupt, how this interrupt will be given. That structure vector table we seen. I drawn that vector table in the lastly. The vector table has been
just a minute, sir.
connected from the iPad.
Some interrupt.
Because of that, this is your vector table.
Yes. Okay, sir. Sir, proceed.
So, this vector table for your interrupt.
So just a minute, sir. I can't able to.
What is this vector table?
Interrupt
vector table. We call this as interrupt vector table of 8086. We call this as interrupt vector table of 8086. Okay, so if you clearly see, we already know we have two types of interrupts, internal interrupt and external interrupt. Okay, so that internal interrupt, external interrupt, all that things we see.
Sir, what is happening?
So after the interrupt is obtained, what happens? What will the CPU communicates? The CPU will communicate.
Is there any other classes going on?
Said that. So that vector address Ella communicates actually how it is communicating and all the things we need to see. So from this block diagram, we clearly understand that. So first what we have seen, that is nothing but the interrupt types. Type 1, type 0, type 1, type 2, type 2.
Just a minute, sir. There is we can't able to mute him.
And next is nothing but what? If you clearly see, the second is nothing but your
content. Yes, sir. We can't able to mute him, sir. We are just looking at the prompt.
Interrupt service routine.
Sir, kindly eliminate the
instruction pointer. CS means code segment. Okay, code segment register. So we have instruction pointer and code segment register connected to the interrupt service routine. So that content will be drawn in that boxes. So we have every type key, we have certain amount of space. So that will be represented with an address. That address is nothing but 4 zeros colon 4 zeros. So that is nothing but your IP that contains it takes two addresses, 4 zeros and 4 zeros 1. Similarly, CS contain two addresses, 3 zeros 2 and 3. Okay, it will be reserved for totally 4 bytes of data will be there, 2 for IP, 2 for CS. 2 for IP and 2 for CS. So it will be reserved for some type of interrupts. That type of interrupts are nothing but divide by 0 interrupt, single step interrupt, reserved for NMI, and INT single type interrupt, and reserved for INTO.
So just a minute, sir. We can't get hold of that.
Lastly, 2 byte instructions of INT.
Sir, somebody
So
else is some other class also. Somebody is in both the classes.
Yes, no, sir.
Zero interrupt.
Just a minute, sir.
And we did not study these two type of 2 bytes of interrupt INT sites.
Yes, sir. Yes, sir. Now we have identified.
Yes, sir. Shall we proceed now?
Yes, sir. Yes, sir. You can proceed, sir.
Chiranjeevi. Remove. Okay, sir.
No, you can proceed, sir, please.
Okay, sir. Sorry, actually, because there was some other voice also. No, I could not proceed actually.
We can actually able to control from our side, sir. That's why it has taken some time. You can proceed now, sir.
Oh, okay. Okay, sir. Actually, so what we have done was we have changed the load and the various loads we have identified. What are the potential areas and how the combustion is taking place, so that we are able to optimize the unburned carbon in the bottom ash and fly ash, and the maximum boiler efficiency was maximized. And we have, in this way, what we have done, we measured the damper position at various places, that is the wind box dampers, and there was a mismatch. So these mismatches were attended, and there was an improvement in combustion. So these are the recommendations which we gave, and which has helped in reducing the combustion unburns. So these resulted in substantial savings in terms of bottom ash unburned. From 6% we could reduce to 3% bottom ash unburned. Then there were issues related to combustion of oil guns. What had happened was actually the guns were not proving. I mean, there was no fire immediately when you admit oil into the system. So what we had done was there is a study was done. The temperature profile of the guns were mapped and found that there was temperature reduction was happening in the transportation of fuel oil from the fuel oil pumpers to the boiler because of the loss of insulation. So we have increased the temperature, and additionally the velocity of the coal the oil nozzles were also checked, and they were addressed, by which the combustion of oil also improved, right? The detailed energy audit, what we do is a comprehensive audit provides a detailed energy project implementation plan for a facility, offers the most accurate estimate of energy savings and cost. It considers the interactive effects of all projects, accounts for the energy use of all major equipment, and includes detailed energy cost saving calculation and the project cost. This is based on inventory of energy using systems, assumptions of current operating conditions, and calculations of energy use. This kind of audit also we have done. So in a plant like ours, what we do, every year we make audit plan for various power plant. For each plant we make a plan. Say for this year, for Faraka plant we'll be doing ash handling audit, then water audit, then APC audit, and other plant will be doing some other audit. So this audit is a comprehensive method across NTPC. Not only for a single station, it will be done for all the NTPC stations, so that every station is aligned for energy consumption reduction. So let's see some of our case studies for improving the auxiliary power consumptions. So for this case study, what we have done, we have taken the generation data, gas turbine heat rate, boiler efficiency, auxiliary power consumption, net heat rate. These are parameters were collected and analyzed for improving the efficiency. A 3-year data was taken for a plant for 13, 14, 14, 15, 15, 16, and what was the heat rate, and what was the APC, what was the specific oil. So we have a target of 2498, okay, was achieved versus the baseline target of 2520. I think many of you know that PAT is a perform, achieve and trade. It is a Ministry of Power initiative for reduction of specific energy consumption in various industries. If they don't achieve, what they have to do is they have to purchase energy saving certificates from the people who are achieving the target and more than the target. And each energy saving certificate is traded in the power exchange. And the plants which achieve can sell the energy saving certificate. The plants which don't achieve have to buy from the market, power market. Okay, so which is a huge implication for the plants, those who operate at lower efficiency. So to increase this efficiency, we have done a case study how to achieve this target and save more for earning, so that we can trade these energy saving certificates in the market. So we have done PLF analysis, availability factor analysis, loading factor analysis, then auxiliary power consumption analysis. Based on this analysis, we arrived at various areas where the APC auxiliary power consumption is more, and what are the action plan we should do to improve upon the auxiliary power consumption reduction. So we have drawn a curve for what should be the curve polynomial for each loading factor, so that at this particular loading factor, what is my APC, whether it is more than the normative or it is less than the normative. That way we will be able to identify the consumption at various loads and opportunities for various. Also, we area wise consumption, like we can see, like boiler feed pumps, what is my auxiliary power consumption, Siroli pumps, fan, equipment cooling water, CEP, mills, ESP, CHP, and what is my various areas in which my auxiliary power consumption is happening. This way, we have made the trend of these parameters and identified the potential areas for the places where we can have a huge potential. Say, for example, in Ramagundam plant, what we have done was there was an SCAF bypass. SCAF is a steam cooled coils that is used for preheating the air during the initial startup of the boiler. When the initial startup of the boiler, we have air preheaters. Okay, in the air preheaters, we use the flue gas coming out from the boiler for preheating the combustion air. But once we start the boiler, there will not be any flue gas because the temperature of the gas will be very less. The air cannot be preheated. Then how do we do this? Preheating of the air, what we do, we take steam from the adjacent unit. We take the steam from the adjacent unit and use the steam for heating the air. That is through coil. The air will be sent through these coils. Inside the coil, there will be steam. Because the air passes through the coil, they pick up the heat from the steam, which is inside the coil. So this way, this air gets heated up. But what happens when the boiler is producing sufficient flue gas with a high temperature? These coils are no more required. But we were not having any bypass. The air will be going through this path only. So what happens? Because these coils are there, there will be a pressure drop. The air which is going through these coils, because of the coil, there is a resistance. Because of the resistance, there is a pressure drop. Because of the pressure drop, there is an increase in fan current. So what we have done, we introduced a bypass. When the unit is ready with flue gas, the air will not go through that path, coil path. It will go to the alternate path. There will not be any coil, so there will not be any pressure drop inside this path, because there is no coil, and because there is no coil, there is no resistance. When you admit any flow path, if you admit any flow element inside that flow path, there will be a resistance generated. If there is a resistance, what will happen? There is a pressure drop. Okay. In electrical parallels, what will happen if there is a resistance in the voltage? Anybody? Hello, sir. What happens if there is a resistance in the electrical flow of current? What will happen to the voltage? Sir, are you able to listen to me? Anybody? Hello?
Participants, sir, can you able to hear?
Yeah, yes, sir, tell me. So if there is electrical resistance, the voltage will drop. Okay. Likewise, here also any flow path, there is resistance, the pressure drop will be there, and the pressure drop has to be compensated by increase in loading of the equipment. Okay. So this, by providing an alternate flow path, we were able to reduce the flow resistance, and we are able to reduce the auxiliary power consumption required for airflow. What are the benefits of auxiliary power consumption reduction? We can increase the generation going outside. We can reduce greenhouse gas emission. We can improve net heat rate, and we can reduce variable cost of generation. How we can do this? Direct monitoring by operators, equipment by specific energy consumption through monitoring through online energy management system, remote monitoring of power consumption through specific energy equipment design methodology. These things we created in our plants, through which we were able to reduce auxiliary power consumption. What are the features of energy management system? That is online monitoring, elimination of human error, measurable outputs, compares and identify the efficient process and equipment. Different type of reports like daily, monthly, quarterly, and yearly can be generated automatically. Report generation and archiving is possible. Standardization of the energy monitoring system. With installation of online energy monitoring system, the energy consumption of equipments are classified into the following. That is baseline value, what is the PGTS value, design value, operating value, process variation from 1 year data, operational control, and maintenance control. What are the controls available? We can identify, and how we can reduce the auxiliary power consumption. So this way we made a report on various equipment, that is compressor, coal mill, ID fan, FD fan, pumps, how much they are consuming over period of time. We can take 5 minutes data, 10 minutes data, half an hour data, 1 hour data, 1 day data, even 1 month data. The data is abundant. So the data, using the data, we can identify what is the potential areas at different loads, what is the energy consumption by each equipment. Whether it is people dependent, some people may be more efficient people. They may be seeing at this power consumption. Some people may not be seeing that. So you can vary it. We can analyze it shift wise. We can make hourly analysis. So that who is more concerned about the energy consumption, and those people can be told how much energy we are wasting in each area. So this way it helps to identify the potential areas for energy efficiency. So we have made the trend of all these parameters also. Specific energy consumption. So for a pump, what is the specific energy consumption for a pump? What is the pump power consumption per liter of water? Okay, for a pump. For a air fan, it will be per ton of airflow. What is the power consumption? So this way we were able to identify. Also between units, say if there are 3 units in a station, we can, and similar design, we can identify what is the unit 1 consumption, what is unit 2 consumption, what is unit 3 consumption, whether is the difference between unit 1 to 3, why the difference. So these kind of analysis also we were able to make through the data which is available online. At a particular time, we will be able to see all unit parameters at a single screen. This helps us to identify the potential areas for energy efficiency. Okay, sir. So we were making for every equipment what is the power consumption, absolute power consumption, and the specific energy consumption. This was helping us to identify the potential areas for improving the energy consumption. So we can see the trend, which equipment is, how it is drawing the power at various loads. These are possible use of online energy management system. Then we can even make the drawing of the equipment on the complete, the temperature mapping, parameter mapping is possible. Whether this particular temperature is more or less at that particular point, why? Then this whys will lead to how to. The whys will lead to how to reduce. The hows will make us to think how to reduce the energy consumption. See, you can see here, one equipment is consuming 3 megawatt, another megawatt is consuming 2.9 megawatt. Why this difference? So this difference can be addressed. We can make action plan for addressing these issues. So this way we can make how we can improve upon the auxiliary power reduction target, and we can achieve that target to improve upon the operational maintenance control or energy management control. These are the three control qualitative tools which we were using for managing the energy consumption, which in turn reduces my internal energy consumption, which in turn increases my chances of exporting more power, which in turn gives me more profit. So what we do, we look at each equipment wise and what is my area for potential energy consumption. What we do, schedule change our equipment as per energy deviation. Suppose if a particular equipment is consuming more, and we normally have standby equipments for each system. So equipment with lesser power consumption will be operated mostly, and the equipment with a higher power consumption will be stopped, and it will be given for maintenance. And the maintenance person will be identifying the area why it is consuming more. Then that can be addressed. So this has resulted in the benefits like auxiliary-wise benchmarking energy consumption, a reduction in specific energy consumption, energy resource planning, eliminating inefficient energy operation, predictive maintenance, root cause analysis, measurement and verification. Once you change over the equipment and we know whether it is an increase in output, that also will come to know immediately. So this has helped in identifying the areas and addressing the gap areas. So you can see that how much savings we are able to achieve by doing various APC reduction plan. Stopping of one pump in winter. See, when there is a cooling equipment required, the winter in some places the temperature of the water goes as low as 5 degree, 10 degree in northern states. There we don't need too many pumps. What we do, we stop number of pumps, which helps us to identify the auxiliary power consumption. When the coal quality is good, we reduce number of pulverizers so that the same load is achieved by running less number of mills. This way, all the potential areas we identify with various methods, and we implement those methods, and we save in energy consumption, which results in substantial savings of auxiliary power consumption. This way, we were able to bring down the auxiliary power consumption. In turn, we were able to improve the net heat rate of the stations. Right? So this, how we are able to improve upon the, you can see that we have done coating of impellers. Impeller coating is, suppose if the surface of the impeller is rough, what will happen? There will be a more power consumption. So to make the smoother impeller inside coating is done. So we have done a coating which resulted in substantial saving of 1%, that is 4.65% efficiency improvement of the pump, which has resulted in huge savings of 76 lakhs. So this kind of improvements actions we do, and we identify the pump cartridges. If they are worn out, we recommend for replacement of impellers. So this way we improve upon these operational aspects to improve upon the energy reduction, energy consumption reduction. So we compare with various units, and we identify the areas for potential power savings. So this way we use the data for analyzing the power consumption between units, between stations, between plants, and we even benchmark with other stations of private players so that we are able to achieve the lowest energy consumption norms in our plants. So till now, anybody has any questions?
No, sir. No, sir.
So we have we have gone for complete replacement of lighting fittings, replacement of ceiling fans with light energy efficient equipments, and we have installed solar power. We are having reservoirs, and one of our plant at Ramagundam, we have installed 100 megawatt floating solar power plant on the reservoir. We have put, because there are two purposes. We don't get space for putting solar power, but there is a reservoir which is used for power plant. Huge area is available. One way we got the area for the putting the solar power plant. Additionally, because the water is exposed to sun, there is a evaporation losses. So that helped in both way. We were able to identify the area for solar power plant. Also, the evaporation loss of the water also has come down. This is also has helped us. Hello. Yeah. So this has helped us to improve upon our harnessing the potential available in the nature. So we have put up 100 megawatt floating solar power plant at one of our plant. So this way we always look at it, options wherein we are able to increase our profits by doing energy efficiency in our way of working. These are various steps which we have done to improve, and what are the potential savings we have achieved. You can see that in 1 year we could achieve 2.57 crores savings due to various efforts which we have taken. So this way we are able to achieve energy efficiency which has results in lesser energy consumption. Another year 2.87 crore. So this way, lot of energy actions we are to improve upon the energy consumption. You can look at various options. So we have even gone for LED of complete install. You can see we are able to achieve the same illumination levels with less power consumption. We are able to see the pictures, and the beauty also increases with LED lighting. You can see that. So these are the investment and the savings. So these are the things. Also, we have put one equipment called light pipes for harnessing daylight to office rooms. You can see those things also. These are the light pipe which takes the ambient light and it illuminates inside our rooms. But it only takes the light, not the heat. If you keep the room open, we may say get the same illumination, but that brings in heat also. But these light pipes bring in only the light, not the heat. These kind of light pipes we have installed at various places in our power plants, which help us to improve the lighting illumination without any power consumption. It's only collects the light from the atmosphere and gives it for illuminating our rooms. These are the solar power panels. Parkings were converted into solar rooftops. Wherever we find potential, we use it for improving the potential of these areas, and we help in reducing the carbon footprint. So we have put wherever this area available in our buildings, we have put solar. So these are the benefits which we were achieving and we continue to achieve. Okay, sir. So we'll stop here, sir. We'll give for 10 minutes for the question and answer, sir. Okay. I have one meeting at 10:45. So I have to leave, sir. That's why.
Sure, sir. Sure,
Okay,
sir.
so I give for 10 minutes for your question and answer. Then we can close at 10:45.
Sure, sir. Participants, it is now your turn. If you have any questions to our experts, you can discuss now.
Excuse me, sir.
Yes, sir.
Yes, sir. Sir, thanks for a nice presentation, sir. Sir, I have some few queries in. Sir, during your course of study of doing these energy audits and all, have you referred any design-oriented problems to the design team, and then they did some analysis, and then they have given any design corrections for, and that would have been enhanced the energy efficiency?
Yes, sir. In some of our boilers, we were finding left-right mismatch in the older generation units. So these were analyzed and it were referred to our engineering team. And the later stage units, the later generation units, those left-right mismatch were addressed by properly taking it with BHEL. Mostly our units are supplied with BHEL, and they were able to correct those changes. By making those changes, because in the running units, it is very difficult for making large scale changes, the existing units. For the new units, we do. But in even in existing units, what we have done in Ramagundam, we have added additional coils in the economizer. By adding additional coils in the economizer, we were able to reduce the flue gas temperature going out to atmosphere. The flue gas temperature were in the range of around 170, 180 from the air preheater, which were going outside the ambient. So we
Thank you, sir. Thank you very much, sir.
we were able to do it in the running unit also. But large scale changes, we will not be able to do it in the existing units, but we do it in the upcoming generating units. So that whatever the problems we face in these units are taken care while the design stage itself.
Okay, thank you, sir. Thank you very much, sir. Sir, have you been involved in the renovation and modernization of power plants and in this particular area, sir? Renovating.
Yes, sir. Actually, in certain units, like mostly what we were doing is in renovation modernization. We were doing it only for the C&I side, control and instrumentation side. Okay, largely we were doing it for control and instrumentation side. Our R&M.
Thank
Hello?
you, sir. Thank you very much, sir. Yes.
Because actually this becoming obsolete system, we are going for DCS from the earlier relay-based system to DCS and max DNA. Those kind of things we were going for the older generation units. Recently also we have completed Faraka stage 1, which was around 35 years old. We have completed this ESC. They were hydraulic controlled units. We have made to electro-hydraulic governing system were implemented. Even the this regulator restricted governor mode of operation were also implemented in these units with the modern control systems.
Yes, sir. Participants,
Thank you very much.
if you have any doubts? Any other doubts from participants? Okay, sir. I think no doubts from participant side. Thank you very much, sir, for spending your valuable time with us. And your session was very informative and very fruitful to all the participants. Thank you, sir.
Thank you, sir. I will send you the presentation, sir.
Sure, sir. Sure, sir.
Okay, sir. Thank you.
Thank you very much, sir.
Thank you all participants for your patient listening.
Thank you, sir.
Participants, feedback and attendance form shared through the WhatsApp and to your registered email. So please submit that. And the test you have afternoon from 2:30 to 3:30 p.m. Okay, so we will share the same thing through registered email and through WhatsApp also. So the next session will resume at 11:30 a.m. Please join at 11:30 a.m. Thank you.
Sir, can you send the PPT, sir?
Yes,
I'm Angoli.
yes, madam. Evening, by evening, we will share whatever the PPT we have received from the expert will be shared through your registered email as well as through WhatsApp, madam.
Sham?
Yes, sir.
Let us post the whole recordings in YouTube, and we will have them linked to them. Like sharing the PPTs wouldn't be apt. Sharing the video sessions, it will be helpful for them on the long run.
Sure, sir.
Okay, fine, thank you.
Yes, sir.